It's chapter 3 with the medical particles and the transformer. So I've taken some of the advice that was sent my way about changing the lighting and changing the surface. So let's see if we can get a better response or a more visible response. So of course this is still my negative 200 mesh metal filings, very, very fine. Just a piece of wire connected to the transformer. Set it there. Come on, baby, focus. Let's see if I can get it focused. There we go. Okay, here we go. 3, 2, 1. There we go. What I noticed from this time, and it's happened every time, I just don't know if I've mentioned it before, is the rapid appearance of mountains, is what we'll call them. You'll notice it's essentially instantaneous. You will see an area that is devoid of metal filings, and the next second or millisecond, it will be completely covered in metal filings. Now, what's interesting is, depending on how I put the electrode on there and how thick the particles are, will completely depend on how the whole thing works. So I'm just going to let this buzz along here for another few seconds, and then I'll shake it up, reset it, and do it again. And let's get my little probe stick. Oh, it's interesting is to see the little cloud, what I'm calling cloud patterns right in through here, where they just appear and disappear, which is what I was talking about before. But if I get it right, if I get the position of the particles just right, you'll see entire mountain ranges like this thing just appear and disappear. Okay, let's do a reset. And try this. 3, 2, 1. The edges of it are in strong motion now. That's probably where the least amount of, or the least amount of particles are. I've noticed that the thicker the particles, the longer they take to become active. And there we go. Is it going to keep doing it? Did you see this action right down in here? How it pulses mountains into existence and then disappears them in the next pulse? This sunburst effect is kind of cool. I have not seen that one before. I mean, we did see the little clouds at the very first time we did it, but now it's clearly, it's like a half-dome sunburst effect coming out from the point of that wire. Anything else? No? We're just going to do that? Oh, there we go. Nice. What I still don't understand is why it stops and starts. This is me breathing on it, blowing a little bit of air on it, wondering if that's what was causing it. And it's not. It didn't do anything when I breathed on it. Okay, are you going to do anything? Anything else? Okay, let's reset it again. And again, as you probably noticed, I'm just using a single electrode. A double electrode, I get a very vigorous effect, but I'm just interested in this moment in just a single field. A single electrode. Boom. There we go. Okay, for this next one, we're going to watch this for a minute. This next one, I'm going to reposition the wire and change it up, bend it in a different shape, and see what we get. Oh, that's cool. And there goes the bridge. See, right there. Just when you get whole mountain ranges, or in this case, a plateau that just appears when nothing was there before, and it's instantaneous. This whole idea of the electric universe that says that mountain ranges are created very, very quickly really, I think, has a lot of evidentiary support right here. Now, yes, I know this is AC current, and we can argue about whether we find AC current in nature or not. But remember that this is just one side of the electrode where it is pulsating, but it's not connected to the other side. So you get a bit of a DC pulsing effect when you don't have both electrodes in full contact with each other. Is there DC pulsing electric effects in nature? Yeah, there are. Yes, there are. That's pretty cool. So it looks like this is now finally stabilized. A little bit of action down here, a little bit right here. And now we're going to change the shape of the electrode. So I just finished watching Andy Hall's part 10 in his Eye of the Storm series, and I just was struck again with the idea of how electric currents are inside planets. We're not taught that. We're not even given that to consider that that's a thing. And yet he points out that how you have electrically dead planets don't have a lot of reaction. Electrically live planets do. And I think we've got and can collect a lot of evidence for that. He pointed out Mercury and Mars, compared them with the Earth, and I think that's a valid consideration. Okay, pull it down, focus again. Here we go. 3, 2, 1. Okay, a little bit more reaction with the shepherd's crook shape. What's interesting is this really reminds me of that that shape down in southern Utah that Robert Hawthorne has investigated, Upheaval Dome. Just looks so familiar to Upheaval Dome. And what's interesting is that we get that type of look that Upheaval Dome has without having a plasma discharge. We know that we can create a crater with a mound in it with a plasma discharge, with an arc discharge. But here we see something very, very similar to it without a plasma discharge, which is really interesting. Layering. Layering without lava flows. Right there, guys. That's really cool. Okay, that was fun. Let's try a different shape. Let's go almost full loop. Oh, what's interesting is you can still see the remnant of the shapes here. There's the, what I called my miniature upheaval dome, and then the canyon that it was associated with. I mean, still, it's like burned. I don't know if burned is the best name for it, but it's adhered into place, which is really cool. Okay, focus, and 3, 2, 1. One thing that I've also noticed that I've been doing a lot of off-camera work because I'm really trying to distinguish. Oh, that's pretty. I'm really trying to distinguish whether these shapes are cymatically created, in other words, vibration, just the vibration of the AC current, or whether it's actually the fields. And I have, it looks, honestly, if I have to be completely honest, it looks like it's a combination of the two. There clearly is vibration involved, and there is clearly electrical field motion involved. And I know that because on one of the off-camera experiments I did, I took, imagine my little bamboo skewer here is the electrode, and I just dangled it in the air right above the filings, and I did get motion of the filings. Now I had to get it down pretty close to do it, but I did get motion. So meaning that the wire was not in physical contact with the container at all, which means there could not be any physical vibration at all. So I do know that there is electricity involved, electromagnetic field effects in here. That's kind of cool. What's neat about this is it's almost never the same each time that I do it. Getting a little shadowing effect right in here. And a lot of creation. If you just watch any of those individual ridges to see how long they last. 1, 2, 3, 4. I see 4 right here. Now let's see how long they'll last. There's motion. Can you see that on the camera? Yeah, they're barely visible on the camera. Oh, wow. But wow, 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 wow. Look at that. Look at that. Wow. Boom. Goodness sakes. See, that's what I'm talking about. Imagine if that effect, if you saw that effect on the surface of the earth. That would just be stunning. How you couldn't even have words for that. And it would be unlikely that you could survive. If you were standing like right here, there's no way you could survive. You'd have to be way far away to survive something like that, I would think. Imagine if you were in a cave. Imagine the sounds that you would hear. Wow! Wow! I mean, clearly there's the buzzing that we can hear with this. I wonder if we were to scale up that sound, what that would sound like on a planetary scale. Wouldn't that just be terrifying? I mean, it really makes sense to me now how our mythology is filled with stories of howling monsters, of incredible light displays, in all the stories of the gods hurling thunderbolts at each other and causing massive upheaval and destruction. And you're like, oh, those stories had to come from somewhere. And that somewhere was our solar system in disequilibrium. The planets were not in the structured orbits that we see them now. They were getting to that point. And as Velikovsky pointed out, Venus, apparently we witnessed the birth of Venus, and that threw everything into chaos and caused all sorts of problems. But can we see the type of electrical effects that we believe happened back then? Yeah, we can. Yes, we can. All right, let's change that electrode out. Let's try some harsh angles now. We've had some nice soft angles. Let's see if I can, I might have to get some tools for this. Okay. Whoa, where are you going? Come here. All right, this is a food break or a bathroom break while I get this set up. Okay. And sit nicely. Don't touch the camera. All right. And once again, you can still see the remnant of that. That was the original position. Now I can move this, but it is, oh wow. That is really kind of locked, or should we call it fused into place? I think that's an appropriate word. Okay, focus. Good. And 3, 2, 1. All right. So apparently with Van de Graaff generators, They're those big balls that you see in science labs that if you put your hand on it, your hair stands on end. The reason those work is because there's no sharp edges, and the electrons, as they're collected on the big ball, spread out homogeneously or smoothly across the whole surface of it. And when I've made my own Van de Graaff generators, one thing that you're told, you must not have any sharp edges, because that's the tip-off point, that's the diving board, the exit door for the electrons. They will favor sharp edges on any surface. And as you noticed at the beginning of this sequence, they jumped off right there. And I knew that was going to happen. That's why I did this configuration. I wanted sharp points aside from just the end of it right here. I wanted to see if we would see electrons jumping off and reacting, and we did. Right there. That was the main point. This one, not so much, which is kind of interesting, and this one, not so much. And not even the sharp-tipped end. It was that one right there. But I think the only reason for that is because this end is actually bent up and in contact with the bowl, whereas this point isn't, and that point is in contact with the yellow base, meaning that this one is the closest one, so you're going to have that reaction. Well, that's fun. So I'm thinking now, or no, TJ Ransom made a comment on this. I sent him a video of this, and he said, this has good possibilities in the art world. Couldn't agree with him more. I mean, this is looking very artistic. Oh my goodness sakes. Apparently we just hit the right depth of powder. Oh, that is just cool to watch. Oh my goodness! Do you see that mountain almost completely evaporate right there? Oh, now it's back. And whoa, now it's changed. Goodness sakes, look at that. And now it's basically 3 islands. Wow. That's really cool. Look at all this action going on in here. Oh, that. Love it when it does that. What's interesting is I've had other comments come in that says, you know, they're magnetized, and when they become magnetized, they stop moving. That definitely plays into it. And I have seen magnetization take place, and honestly, it's really like an electromagnet, because the edge of the alligator clip will actually, when it's not energized, will actually pick up different particles and act like a magnet. But they are easily shaken off. And even though it's not energized, I can easily shake the particles off. So yes, there is magnetism involved, and what do they call it? Non-permanent magnetism or electromagnetism. That is part of this whole sequence, to be sure. So are they magnetized? Yeah. When I de-energize it, do they stop being magnetic? A little bit. Yeah, they do. So do I feel like magnetism plays a huge role in what causes the whole thing to stop? No, I don't. I think it has more to do with the thickness of the particles and the strength of the field around it more than anything. But what I don't know is why it goes through these little moments of boof, 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 boof. It's like costume changing. Sudden and dramatic costume changing. Wow. Look at these little mountains right here. Just goodness sakes. All right. Definitely going to start doing some hard angled configuration of wires. I'm going to have to go out in my shop and get a hammer and create an even starker angle. I just bent these with some pliers. I'm going to get a hammer and try that, because that seems to get the biggest effect that we've seen all day. but I've tried a bunch of different things. I've tried these fluid or this stuff dissolved in water, sprayed it around in water, tried the electrode in different configurations, cannot get any movement with it in water. I don't see anything. Oh, here's something I can try. Let's try flipping it. It's kind of like a reverse vacuum cleaner. Like, no, this is a no dirt area. Oh, wow. Wow. Love seeing that. That is just cool. All right. Well, there's chapter 3. That was fun. Oh, I better turn that off. I almost touched the electrode with my hand. And I can tell you, that's not fun. I got nailed yesterday, just accidentally playing with some lights, trying to energize some LED lights, and woo, I touched it. Bam! That was not a fun day. Anyway, if you have any ideas for chapter 4, let me know, and I will be happy to implement them. Hopefully that video was a little bit better. I like the background. Give me any notes if you thought the lighting was great, not so great, whatnot, and any other ideas, and I will make them happen.